Hey everybody, today we'll do another math problem. Today we'll do a basic differential equation problem. I will say basic, but when you're talking about differential equations, you're talking about still doing some math to solve a simple problem, right? So, so, so let's do a problem that requires separation of variables, right? So we do what is called separation of variables, right? So in this case, we will do a problem that is, it will say solve by the separation of variables or whatever, right? You can say solve by now the problem will be like this. The problem will be x, right? And then it will have dy dx equal to 4y, right? So our goal here is to separate the variables. Right? So we can have only x and y on each side of the equation. So what we can do here is multiply by dx, right, on both sides, and we will have x dy equal to 4y dx. Now, my next step here is to somehow get the y's on one side and get the x on the other side. So here what I can do is divide by x. Alright, so I can divide by x on both sides. Alright, and divide by x on both sides here, right? So that cancels out, and I have dy is equal to 4y, and then I can put this in parentheses, so I can say dx over x. Okay, so I still have y here in this side of the equation, right? So what I can do is divide again. Divide by 4y. Divide by 4y. Now, what I have here, if I divide that, right, I will have dy over 4y equal to dx over x. Okay, so we have actually separated the variables, right? Now we need to do the rest, right? So now we can come here and say, okay, so dy over 4y equal to dx over x, right? So here I got a dy over 4y is equal to dx over x, right? Now what I can do is integrate on both sides, right? That is the next step. Remember, the differential equation was given in terms of derivatives, right? It was given in terms of derivatives, and we need to find the solution for that equation, which will include a plus c to get what is called a general solution, right? But at the same time, we kind of going backwards to the original equation, right? To before, let's say before this function was taken the derivative of, we want to find the original solution, right? Before this function was given to somebody took the derivative and left it like this. Our job is to work it backwards and find the original, I would say, equation that was before the derivative was taken. It doesn't make any sense. Okay, so now, because it is in terms of derivative, that what the differential equation is. That's why it is called a differential equation, because it was differentiated in order to get the derivative of, right? So we're going back and taking the integral on both sides of this equation. And when we take the integral, now I can factor out the 1/4, right? I can factor out 1/4, and I can just have dy over y equal to the integral of dx over x. Now, what I did is just factor out the 1/4 out, right? And this is equal to 1/4 ln, right, of y. Actually, it will be the absolute value of y. Right? So, absolute value of y equal to the ln of absolute value of x. Right? And then I have a plus c here. Now, I still have some problems here because I have this, I need to solve for y. So, what I can do is kind of rewrite this, right, in a more simple form. When you have a coefficient in front of the natural log, you can actually bring that to the front, right? Kind of is making to exponentiate that function, the natural log. And what I can do here is just basically do it like this: ln of absolute value of y. Alright, so ln to the absolute value of y to the 1/4 power equal ln of absolute value of x plus c. C is just a constant, right? Okay, now the next step is going to get rid of the ln, right? I need to solve for y somehow, so I need to get rid of the ln on both sides. So what I can do here is take the e on both sides, right? Take the e here. And when I do that, I will write over here. So when I do that, right, the ln goes away, right? The ln goes away, and I get y I get y to the 4th 1/4, right? Y to the 1/4 equal x, right? And then remember here you have like bases, right? So that mean that is actually something like still like this, right? But if I have it something like this, then this is a constant anyway. So that's why we don't write this with e to the c power like that, because it's just a constant, right? So what we do here is the following. We do y to the 1/4 equal to, I just bring the c up front, just like that, bring it up front, and I said c, because it's a constant, the e, it doesn't matter because it's a constant, right? Ex, right? I'm sorry, cx. So cx, right? Now, I still have the 1/4 power here. So what I can do is multiply by 4th on both sides, right? So by the exponential like this, right? So multiply by 1/4, right? And that cancels out, right? And whatever I do on one side, I got to do on the other side, right? So just like that. Then y equal to c, right? X c to c, right? To c x, right? C x to the 1/4, right? So that it is called the general solution, right? So therefore, this is called general solution, right? So now let's say that you want to find a particular solution, right, of this differential equation when some number, some function was evaluated at some number x, for example, right? And you want to find the particular solution because this is a general solution. Let's say that you want to find the particular solution and you want to do, for example, just make it. We know that in here is some numbers, just a couple of numbers that are going to make sense, right? Because let's say, for example, if y was evaluated at x equals 0, so x to the 4th power is going to be what? It's going to be 0, right? So c multiplied by 0 is going to be 0, so it's not going to make any sense, right? Because y is going to be just hanging with some value over there. But if we say that find the particular solution, right? If we say find the particular solution at y evaluated, or we can say at y evaluated at 1 equal to 4. For example, find a particular solution at that point, right? At this point, right? In other words, at this point, like this, right? Remember when we did basic math that we actually calculated something is function is evaluated like that, we meant that 1 comma 4, something like that, right? At that point of x, the y value is 4. That's it. That's all it means, right? Right. So let's do a little quick, right? So let's say that you want to find the particular solution of that. So we're trying to find the value of c, right? So here we'll do the following. We'll do, okay, so we know that this is the value, this is the equation, right? So what we do is the y is equal to 4 at x equal 1 in this case, because we have it, the variable can be anything, but in this case we have x, right? So we can do it like this. We can do 4, right? We plug in 4 for y, and we can say equal to c, right? So here we plug 1 to the 4th power, right? Now, so here is going to be what? 1 to the 4th power is just 1, right? So we say 4 is equal to c, right? So, and then guess what? C, which is the same as saying 4 is equal to c, right? Or c is equal to 4, right? C is equal to 4. So now we come here and replace c with 4, right? And in the particular solution for this is going to be the following. It's going to be y equal what? Equal 4 x to the 4th. Right? So that's it. This is the particular solution. All right, this has been for today. We just did a basic differential equation using a separation of variables, and we did an example. Of a particular solution, right? How to find a particular solution when you already found the general solution. Then you use the general solution to find a particular solution. If they ask for find a particular solution at this point, right? They have to give it to like a general. This is called initial conditions, right? So they have to give you an initial condition in order to find the particular solution. You have to have an initial conditions, and the initial condition in this case is that. So at 1, this equation evaluated at 1 is equal to 4, right? So that's how you do it. Thank you for watching, and I hope you learned something in this video. If you do, please give me a thumbs up, subscribe, and share this video. Thank you for watching.